Children, few more questions of the same type. Over here, y is given to be tan inverse cos x minus sin x over cos x plus sin x. And x is given to be greater than 0 but less than pi. I have made a change here which I will explain you why it is so. First, we simplify this. Now, this numerator and denominator, if I divide both by cos x, then cos x over cos x becomes 1, sin x over cos x becomes tan x. In the same way, the denominator reduces to 1 plus tan x. And you know, this is the formula for tan pi by 4 minus x. Because then this 1 can be replaced by tan pi by 4. And here 1 into tan x can be written as tan pi by 4 into tan x. So it takes the form of tan a minus b. Now, can we write this as pi by 4 minus x or not? For that, this angle should lie in the open interval minus pi by 2 to pi by 2. Now, if you see, first I'll simplify it with this, then you will understand why this change is being done. Now, as it is given x is greater than 0 but less than pi by 2 and our angle includes minus x, so I multiply the entire inequality by minus 1. So, 0 into minus 1 reduces to 0. This becomes minus x and you can see the inequality will change because you are multiplying each by a negative integer and this is minus pi by 2. Writing it in proper order, minus pi by 2 is less than minus x which is less than 0. And what is our angle? Pi by 4 minus x. So I add pi by 4 to each of them so that this reduces to pi by 4 minus x. That means the required angle. So adding pi by 4 to each. This will become pi by 4 minus pi by 2. This will be pi by 4 minus x. Pi by 4 plus 0 is pi by 4. Now subtract these two. Pi by 4 minus pi by 2 will be minus pi by 4. And this is our required angle in between, which is further less than pi by 4. So what do we see? Our angle is belonging to open interval minus pi by 4 to pi by 4. So this interval is including all those angles which will also lie in the interval minus pi by 2 to pi by 2. This is part of that interval only. See, if I say this is minus pi by 2 and here it is pi by 2 with 0 somewhere over here. So our angle is from minus pi by 4 to pi by 4. It is in this range. Understood? Which is part of this range. So our angle, whatever angles we are getting, they are lying in the principal value branch only. So y is equal to tan inverse tan pi by 4 minus x can be written as pi by 4 minus x. If you see in the book, maybe there is a mistake or whatever. In the book, this is not pi by 2, this is pi. So just think, if we continue with pi, then this will remain pi, this will remain pi, rest all same. So only this thing we are changing. In place of pi by 2, taking pi. So this becomes minus pi by 2. On rearranging, we get minus pi by 2 here. Adding pi by 4 to each, you can see pi by 4 minus pi by minus pi will reduce to minus 3 pi by 4. That means minus 135 degree. If you see minus 3 pi by 4, in this number line will come somewhere over here. Okay. So you are getting your angle between what? Minus 3 pi by 4 to pi by 4. See, either the angle will be completely in the principal value branch or it will be entirely outside it in some other range. Okay, it cannot be that some angles are within the principal branch and some of the angles are outside it in some other range. Half in one range, half in other range. That will not happen. Either entirely in the principal branch or entirely outside that. If you see these many angles, they satisfy the principal value branch, but these one are not satisfying. So that gives us an idea that the domain which is given here needs to be changed. Okay. Fine. Then see the ninth one. It is y is equal to tan inverse x over square root of a square minus x square. Because it is difference of two perfect square, we know sin square theta can be written as 1 minus cos square theta or cos square theta can be written as 1 minus sin square theta. Moreover, you can see we have this is in the form of a fraction. So if the numerator somehow reduces in terms of sine and the denominator in terms of cos, then the ratio will be in terms of tan of certain angle. So I use the substitution x is equal to a sine theta. That means x over a will become sine theta, or theta can be written as sine inverse x over a. Now do the substitution. Here we get a sine theta. This will be a square. This will be a square sine square theta. From both a square can be taken common. And you can see this 1 minus sine square theta can be written as cos square theta. So both are perfect square. That means on taking square root, the denominator becomes a cos theta and the numerator is a sine theta. A you can cancel out. Sine theta over cos theta will be tan theta. And we get tan inverse tan theta, which can be written as theta. We can support it through this condition also, why we are able to write it theta, that I'll explain here. So if this is theta, then theta is how much? Sine inverse x over a. So what are we getting? Y is sine inverse x over a. So we need to only see, is it satisfying the required domain for the function sine inverse x? For sine inverse x, x has to be within the closed interval minus 1 to 1. Over here, our angle is x by a. Now, mod of x is strictly less than a means x is less than a but greater than minus a. So, x by a becomes less than 1 but greater than minus 1. So, this number is in the open interval minus 1 to 1. So, it contains all those values which are part of the closed interval minus 1 to 1 only, though minus 1 and 1 are not included. We are not getting any value for x over a which is outside the closed interval minus 1 to 1. So, therefore, tan inverse tan theta can be replaced by theta. Then one last one of the same type. This is what tan y is given to be. They are saying a is strictly greater than 0 and the value of x is strictly greater than minus a over root 3 and less than a over root 3. If you look at this expression, you will get an idea that we can try to convert it into the form tan thrice of theta. Okay. So for that, what we do, we replace x by a tan theta. So theta will be tan inverse x over a. So see quickly, if we do the substitution, we get y to be tan inverse 3. A square we were already having and x is a tan theta. So this becomes a cube tan theta. And x cube will become a cube tan cube theta. In the denominator, this is a cube. Then thrice of a, and because this is x square, we get a square tan square theta. So this is also converting into a cube. So you will find from the numerator as well as from the denominator, we are able to take a cube common. Once a cube is taken common and cancelled out, this is 3 tan theta minus tan cube theta over 1 minus 3 tan square theta, which is the formula for tan 3 theta. So see, y is now in the form tan inverse tan 3 theta, which can be written as 3 theta, and substituting theta here, y becomes 3 tan inverse x over a. Let us see, can we convert it into 3 theta? See, this can be written 3 theta if 3 theta will belong to the open interval minus pi by 2 to pi by 2. See, this should belong to the open interval minus pi by 2 to pi by 2, and we can show that it is belonging to this interval using the given condition. It is given x is strictly greater than minus a over root 3 and less than a over root 3. Replacing x by its value, which is a tan theta. You can see there is a in all the three numerators. So you can cancel out a everywhere. So in the center, the expression is tan theta. This will become 1 over root 3, which can be replaced by tan 30 degree or tan pi by 6. This will be minus 1 over root 3, which will be minus tan pi by 6. We can write minus tan theta as tan minus theta. So I have written it as tan minus pi by 6. Okay. You can see the angles are increasing. Minus pi by 6 theta and then pi by 6. Now in this range, you must have seen as the angle is increasing, tan of that angle also increases. So we can say theta is greater than minus pi by 6 but less than pi by 6. Now you compare it to your angle. Our angle is not theta, it is 3 theta. So I multiply everything by 3 theta. So this on multiplying with theta 3 becomes minus pi by 2. This one multiplying with 3 becomes pi by 2. So 3 theta is greater than minus pi by 2 but less than pi by 2. So we were able to write tan inverse tan 3 theta as 3 theta. And so the result.